All right, you're welcome to another class in DevOps from Zero to Hero series. And this is a free YouTube course that I have personally started to help you understand everything that involves or that involves DevOps. So if you have not watched the previous videos we made or the previous classes, please ensure you go watch them because they are very important so that you understand every concepts in DevOps and you can um, do your real-time projects easily, right? So in the coming class, we'll also we'll also work on real-time projects, and I will teach you every step-by-step guide you need to follow to ensure that every task are done easily. So in this class, we will be discussing on some network basics for DevOps. So I will explain the networking basics for DevOps. I will be explaining this to you, and please, I really want you to pay a very good attention to it because it is very important. This is a very important topic for you to know in DevOps. As a DevOps engineer, you'll be working on a lot of tasks that involves network, and if you don't really know how to go about it, that will be a problem, right? So all right, so let's start. You've been hearing about network or networking, for example. You've been hearing about network for a long time, and you know you don't really know what it means or what this what the network fundamentals are. So this is just a class for you to know. This is just an opportunity for you to know what it is. All right. So now, when we say network, what is a network? Right. You can ask yourself, what is a network? A network is simply, a group of devices that are connected to actually share data, and it is that simple, right? For example, it is a group of, I can say computers or devices that are connected so they can actually share data and resources. Let me give you an illustration. Take for example, you have your Wi-Fi, right? You have your Wi-Fi at home, and then you from that Wi-Fi you can connect many things to it. You can connect your smartphone, you can connect your computers or your laptop, you can connect your smart TV, you can connect everything to it. You can connect anything connectable. Let me use that word to it to actually, and in that process, right, they share data, they share resources. You understand? So it is a group of computers or devices that are connected so that they can actually share data or they can share resources together. So, and that's why they will always tell you that whenever you're in public, it is not every Wi-Fi you connect your devices to, because it can actually cause a lot of troubles, right? There have been many instances where people just randomly connect their computers or their smartphones, to public Wi-Fi's or something, and then from there they access their laptops, they access their computer, they access their smartphone, and do some sort of illegal activities, which so that's why in that process, right, they all these things happen, all these illegal things happen because the Wi-Fi is sharing data, is sharing resources to your smartphone, and vice versa. Your smartphone is also sharing the resources to the Wi-Fi, so it is connected together so they can share data, so they can share resources. So if someone gets hold of the Wi-Fi, if an hacker, for example, can actually hack the Wi-Fi, then the person can get access to your computers or your smartphone, whichever. All right. So now the next one is just the types of networks. We have so many types of networks, and I'll be explaining them one after the other. So the first one here, the first one here is LAN. We call it LAN. That is local area network. When we say local area network, right? Local area network, it connects computers and devices in a limited area, right? In a very limited area, like your home, your office, or schools, right? In a very limited area. So in this sense, if these devices are connected and you are outside home, or you're outside your workplace, or you're outside your office, right? It can get disconnected. You understand? So it can connect computer, it can connect devices in a very limited area. And this local area network, right? It has a very high range of high speed. It is very, very fast. It is very, very, very fast because it uses Ethernet cables, right? It uses Ethernet cables, so it is very, very fast in this sense. So you know office can office network can actually connect to multiple computers, using using a server. Are you with me? So that is local area network. So it can be used at home, like home Wi-Fi, you know, office network as well. It can be used in the office or school, right? And this network is very, very, very far. I mean, very, very fast. All right. So the next one is WAN. WAN, that is wide area network. When we say wide area network, wide area network covers a very large geographical area. For example, a part of the world, or like a country, for example. Now, let me give you an example. Recently, there are issues. Well, I don't want to be political here, but just to give example so that you understand what is happening. I'm not being political. I'm not affiliated to you know, any political group, right? I'm just trying to give example here. So recently, there there are serious protests going on in Iran. There are very, very serious protests going on in Iran. Let me check if this is still recording. All right, still recording. So there are very, very serious protests going on in Iran, where Iranians have actually alleged that government, the government or the regime there has been killing innocent or peaceful protesters in this sense, right? And in that sense, they have disconnected the internet in the country. So the people in the country don't have access to internet. One, they don't have access to electricity, they don't have access to internet. So now that gives them time to actually commit every atrocities they want to commit, because the whole part of the world are connected to the internet. Are you with me? The whole part of the world are connected to the internet. So we that are in Africa, or we that are some people that are in the US or Europe, some part of Europe, can actually see what is happening. So because of that, the regime there, they actually cut off the internet connections so that everybody in Iran don't have access to internet. So they will not be able to publish any videos, or they will not be able to post any pictures of what is happening. So this gives the regime that super hand to actually commit whatever atrocities they've committed. So you know there have been reports that they have killed thousands and thousands of protesters, and right, we've seen it online, right? Which is quite very, very unfortunate and very, very bad. You understand? So in this sense, Starlink, that is owned by Elon Musk, right? Starlink, that is owned by Elon Musk, now decided to to move the internet. Elon Musk decided to move Starlink to Iran. You understand? So it will actually enable the Iranian to actually connect um to the internet. Are you with me? So they can actually speak up and speak about what is happening. So in this sense, Starlink is an example of one that is wide area network, because moving to an area where there's no network, or where there's no internet, gives the Iranian, leverage or gives them the opportunity to actually come outside and speak about what is happening in real life, right? So Starlink, for example, is an example is under is one network, right? So that is wide area network. So that is that. And we can see, for example, the internet. That's the largest one we have. The internet. We are all connected to the internet. Every you that you are hearing me presently, you can hear me via the internet. If there's no internet, there's no way in the world that you will hear me. All right. So that is an example of one. I hope you can understand that. The next one is MAN. That is Metropolitan Area Network. Metropolitan Area Network covers a city, right? It covers a city or a large campus connecting multiple LANs and CANs. It connects multiple LANs. It connects multiple LANs and CANs. For example, we have citywide government area, right? Connecting offices and data centers. Are you with me? That is why the government can actually have access or control the internet. Are you with me? Using this, they have access to the internet, they have access to man as well. You understand? So now it covers, city campus. It covers large campus, it covers the city, it covers many lands or cans. And for example, right, we have the city-wide fiber network. But let's just check the example together. It is quite easy. Example of man. That's Metropolitan Area Network. So you can see the picture, example of this picture, you can see we have too many examples here. Let's just look for one that is okay. Let me check this out. So look at it now. We have metropolitan area network. You can see this is more like a city. This is more like a city. And in this block, take for example, in this particular block, we have many LANs. We have many we have many laptops, many desktops, many computer, many smartphones that are connected to this part. Also this as well. So it is metropolitan area network that connects everything together. So in this sense, they can share data, they can share resources and others, right? So the next one is PAN. The next one is PAN, and PAN is what? This is a personal. It is a personal area network, right? It is very, very small. It is very small network for personal device. It is meant for personal use, and it is just within, it is just within few meters. It is just within few meters away. For example, you are connecting your Bluetooth to your phone, right? Or you are connecting your Bluetooth to your headset. In this sense, if you connect the Bluetooth to a speaker, for example, connecting a Bluetooth to a speaker and you play a song, the song that is supposed to be playing on your phone will now be playing in the speaker because it is now connected. It is now transferring data. And the data is from, you can say music, right? It is not transferring the music that is supposed to play on your phone to the speaker. So, for example, if you now move away from the speaker, maybe you move like 5 meters, 6 meters, 7 meters away, right? You'll see that in this sense, the Bluetooth speaker might break, or it will not speak, or it will not sound again. It will not give any sound again because the Bluetooth can only go within few meters, right? If you move past those few meters, then nothing will speak again. It will not be connected, so it will be disconnected. So this is PAN. This is personal area network, right? So for example, we have smartphone that smartphone are connected to like wireless AirPod. You can, when you connect your smartphone to your wireless to your wireless AirPod, or to your laptop, or laptop that uses mouse. Are you with me? For example, the computer I'm using that is using mouse presently, right? If I move it far away, if I move it far away from the computer, if I move the mouse far away from the computer, it will not work because it is using PAN. That's personal area network. All right. So moving next, okay, we have wireless local area network, right? I would say, is it LAN? Or you might as well say LAN, right? And in this sense, right, it is the same as LAN. All right, so LAN is, you know, it is a this is a LAN that uses wireless technology instead of using cable. The other explanation I gave about this, right? This uses Ethernet cables, within the homes or offices, right, for schools. But this, in this sense, it uses um wireless network. Are you with me? It uses wireless cable. So to connect to home, to office, for example, this is exact example of what we use at home. For example, I also use this. It is wireless, right? Connecting. This is my network presently. Connecting to what? To home Wi-Fi. Are you with me? Connecting to home Wi-Fi, and it's actually, will I say, it helps in connecting different devices, different, like your laptop, your smartphone, at home or office, whichever. So that is that. And then the next one is CAN. That's campus area network. Campus area network. Campus area network connects multiple LANs, right? It connects multiple LANs within a campus or a group of buildings, right? So it covers, the coverage is larger than LAN. This campus area network is larger than LAN, but smaller than MAN. The MAN that we explain here is smaller than MAN, but it's larger than this. It's larger than LAN. So in this sense, right, it is more like university network, connecting to labs, connecting to administrative offices, connecting to senate buildings, connecting to libraries and all. Okay, let me just show you example so that let us see example of CAN so that we'll both see it together. Example of a campus area network. So example of a campus area network, you can see these examples, right? Let me use this as an example. So we'll both see it together. Now look at this. Let's take for example, this is more like a campus, like lecture rooms. Let's say these are lecture rooms. Let's say this is just like Senate building or the administrative blocks, or this is more like maybe bursary blocks or whichever. They are all connected to this network here. They are all connected to this particular network. So one thing that it is very, very important, is what? Security. If this CAN or campus area network, if this CAN is vulnerable, if it is very, very vulnerable to attacks, an hacker can easily penetrate through this network, through this CAN, and then automatically, because this CAN is sharing data to this, and this as well. Oh, just a minute. I didn't toggle on this part. All right. So because this CAN is sharing data to this part, to this, and to this as well, hacker can automatically access any data coming from this. It can access computers in this block. It can access computers in these blocks. So you can imagine the number of data or the number of information that will be shared. So that is a typical example of what we're talking about here. That is scan. Now let's move forward. All right. So the next one is VPN. That's virtual private network. Virtual private network. And when we say virtual private network, it is what? Accessing a company's server securely, right? When you access a company's server securely from home. Are you with me? Accessing a company server securely from home. For example, sorry, I didn't write the note properly. So later in the lecture, after the lecture I will go and edit it. Because the thing is, it is not even easy for me to assemble the notes and write the notes, because I spend hours, and I'm not even bluffing. I spend hours trying to bring up the notes so that you can go through with me. You can go through with me easily. So I spend a whole lot of time trying to assemble the notes. So I mean, mistakes are bound to happen, right? All right. So I will make sure I correct it and then send the corrected one in so that you all can see it properly. So VPN, well, let me just explain to you. VPN is just like a secured encrypted network. It is encrypted. It is not decrypted, it is encrypted, that is built over a public network, right? It is built over a public network, but in this sense, it is encrypted so that you know it keeps someone, or it keeps every data or resources that is being transferred very, very secured, very, very, very secured, right? And we can access it is, for example, now when you want to access the company server securely from your home, right? When you're accessing the company server securely from you will need VPN to do that, because when you want to transfer data and you want to do one or two things, right? You don't need to be exposed, because once you are vulnerable, you risk losing a whole lot of the company's data or information to anybody, right? And which will not be a good thing in the long run. So the next one is SAN. SAN, let me see. Okay, it is still recording. The next one is SAN, that's storage area network. I won't say storage area network. It is it's specialized in what? High speed network. It's very, very it is specialized in high speed network that provide what? Block level access to devices. For example, you can make example of enterprises data center or backup server. You understand? So this is example. This is a typical example. Let me just copy it so that we can see the example together. Because I want this to one thing I'm coming before I explain it. One thing I found interesting is the fact that every knowledge we have today, every information we have today, everything we have today, we got this from somewhere. Nobody brought information from heaven. Nobody brought it from his mother's womb or something, right? So it is always important for us to try and get information, not just information, but the right information that would help us on the long run. So this is an example of a storage area network. Let me look at this. All right. Okay, so you can see this is a SAN switch, right? And then we have data sharing from here, from here, from here. It stores some data in this back end. It stores some data in this back end, having database, cloud storage, or whichever data that is needed to be stored, it stores it in the back end. And then we have data coming on. We have data coming forward. Are you with me? So this is just much. This is the types of data centers data we have, the type of network we have. So altogether they are 8, right? So let's move forward in the lecture. All right. The next one we're going to do now is the network devices. We need to know some of the network devices, and I think at this point I will not be in the presentation mode. I will have to just will I say start explaining this normally. So now, so when we say network devices, right? The network devices, they are physical or virtual machines. Please let's take note of that. We have the physical or virtual machines that help what? That help computer connect, one, they help computer communicate, two, and they help them to stay secured on a network. It is very, very important. These three are important: connect, communicate, and then stay secure. The security part is, very, very, very critical in the communication, in the data process, in the data transfer processes. Now, for example, we have a router. A router is, a router connects, it connects different network together and decide where the data should go. Are you with me? So it connects different network together and then it decides where data should go next. Like, for example, it's more like a traffic police, right? Or in this part of the world where we call them road safety, or a road junction, between neighborhoods. For example, now a traffic police or a road safety person, right? A road safety officer, for example, or a traffic police in this sense, they direct what? They direct cars safely, right? They direct cars safely. They'll be the one to stay in the middle of the road. The direct car that, okay, you go to this part, you go to this side, you go to, so they decide, right? They connect different networks together and then decide where the data should go, right? So, for example, let's just see example of a router. So you can see, for example, let's just make use of this example here. Or okay, I think this is still good. Let's see. I don't want to spend much time here. No. Open new tab. But if you look at this, we have the router in the middle, right? We have the router in the middle, and then it is directing where data should go to different parts, right? It is directing where data should go to different parts. So the next one is switch, right? The next one is switch. Oh, before I go to switch, we should know that without router, computer cannot reach the internet. There's no way the computer or the laptop or the devices you are using will reach the internet, that is smartphone or something. Without the router, then no one or no network can actually talk to another network. It is very, very important to know that without a router. Now, the next one is switch. When we say switch, right? Switch actually connects devices inside. It connects devices inside the same network, like the LAN, for example. It is like a power extension board, right? But it is more smarter. It's like a power extension board. It is pretty more smarter and smarter. And then a switch, right, knows which devices is which. A switch can actually differentiate between one device and another. Are you with me? And then it sends data to only the correct device, that is assigned to be sent, right? So that is it. And then the next one is hub. We have hub. Example of hub. Let me just show you example. Yeah, this is an example of a hub. Like this is more like an image, right? Now, an hub is a what? A hub blindly sends what? Data to every device. You understand? blindly send data to every device. This is what they use, initially. This is what they use initially. So it's more like the old version of, how data is being sent, right? It can send data to any device. It can even send to your foes or to your enemy or to hacker, anybody. It sends devices, and it is more weak. It is more vulnerable. Are you with me? So that is hub. And then also we have the firewall, right? We'll talk more about this firewall later in the course. I will explain more about it, though I will still try to talk about it in this lesson, but more of it will be coming later in the course. Well, I think the part two of this network, where we'll be explaining the IP address, the subnets, how subnets are being used, and other more, right? So the firewall, right? The firewall in this sense is like a bodyguard or a security guard to the network. It's like a security guard that actually controls the traffic. It controls what is coming in, it controls what is going out, it controls what is allowed, it controls what is blocked, what is not allowed, right? So that is the firewall. If you are going for, let me say, let's take for example, you are a security guard. You understand? You're a security guard that is mounted, or that is standing in front of a gate. For example, a bouncer, right? And you have been told that anybody that is short, and that is not wearing good clothes, or that is short, and let me give an example. Yeah, let's just say an example. Anybody that is short should not come inside. So what you'll be doing as the bodyguard or as the bouncer is that you will be looking for anybody short not to come inside the event center or the event hall. So if there is someone short approaching you, all you do is to block the person, or you push the person away, or you throw the person to the side because the person is short. Oh my god. So so that is example of firewall. It controls the traffic coming in and going out, right? And then it decides on which is what is allowed or blocked, right? And then the next one is access points. Access point. When we say access point, right? Access point is a what? An access point provides wireless network. It provides wireless network. It provides wireless access. Sorry, to network. It provides the wireless access to a network. This is access point, and then it connects what? It connects wireless devices, right, to a wired network. Let's just look at the example of an access point. Simple. All right. A example of an access point, or is it example of or image of an access point. Now look at it. This is an image, right? These are devices. This is a typical image of an access point. You understand? So what it does is it provides wireless access, right, to a network. Yeah, and that's it. So now let's move forward. The next thing is how devices communicate in a network. It is this part is very, very important. I need to pay close attention to it. So now, how devices communicate in a network. How do devices communicate in a network? You should know that in this sense, right? Let's take for example, you are sending a message to someone. In the olden days, when we write message, right? When we write letters, we write the letter, the address of the person, the home address of the person, and then the letter we want to communicate to the person. Are you with me? And then we'll now send it, right? I'm trying to use this illustration. When we send it through the post office, right? The first thing the post office box will do, the post office officers, right? The people there, what they will do is they will try to check the home, the address of this person you are sending letter to, right? You provide the address of the person you are sending letter to. They will check it, then they will send it through, is it carrier or something. So it is that carrier that will now start to trace the address one after the other till you reach a specific place, right, of the person you are sending letter to. So in this sense, right, we have a sender and then we have a receiver. Are you with me? So now, when two devices communicate on a network, right? Please take note of this. When two devices communicate in a network, they are doing just one thing. They are doing just one thing, and that thing is sending data from one place to another. For example, let me see if I can do it. So, for example, if we have this data one, and then we have this, right, device one and device two here, right? So if device one wants to send an information or a data, right, it starts here and ends here, right? It starts here and ends here. But now, for any communication to happen, right, it needs three things. For any communication to happen, it needs three things. And why did it need these three things? The reason is because computers are not humans. Computers are not human beings where they will talk. They don't have names like my Tofumi's laptop, Tadi's iPhone, or whichever. They don't have names, right? And so, in this sense, right, they will need rules. They will need something to identify with. Are you with me? Computers are not humans. So that is why we need these three things: the IP address, the MAC address, and then the protocol. We need the IP address, the MAC address, that's MAC address, and then the protocol. Now, the IP address is where the device lives or where the device is staying. Let's say, for example, this device is somewhere here, right? And then we have the device in here, and then this device is also inside this place, right? Now, we need the IP address of this device that is here so that when this is communicating, it can go directly to this part. It can go directly to this part. So in this sense now, we need the IP address, the MAC address, and then the protocol. So as I explained before, when you want to send data, when you are sending data, you will need the what? The exact location of the person that will receive the letter. Sending letter, you need two persons, right? The senders and the receiver. But as you are writing your letter, you will need to provide the exact location of the person that will receive the letter, and then the house number of the person. Once you've provided the exact location, you provide the house number of the person so that the person who is going to take the letter to the receiver will go exactly straight to the person's house and then deliver the letter. It is that simple, right? Now, when we say IP address, right, an IP address is a number that what identifies a device location on a network. So every device has what? An IP address. Every device, for example, if you want to check your IP address, you can say, where is my IP address? Or is it, where is my IP address? Okay, is what, not where. What is my IP address? It will show the IP address, the exact location where you are. So you can see this is the exact location. This is my IP address here presently. This is my IP address here, and you can check it from your hand as well. So every devices you are using, either a computer or a smartphone, right, comes with what? an IP address. It is very, very important to know this. All right. So it is just like your house address that tells people where you live. It is like your house address that tells people where you live. So, and in IP address, we have a public IP address and then we have the private IP address. So the public is this one, while the private is this one. I will still explain in the part 2 of this lecture of this network, or in this network course, right? I will explain IP address in detail so you understand it. But let's just try and treat the surface part and know what network entails generally, right? Before we go deep into it. All right. So as I was saying, right, an IP address is just like your house address that tells people where you live, and then our IP address is where the network, right? An IP address tells the network, where your device is presently. It tells the network where your device is presently. Now, the second one is, okay, before I even go to the second one, you can know that now, why do we really need IP address? Why is IP address needed? It is needed because, if you send data without an IP address, right, the network does not know where to deliver the data. You understand? For example, like I cited an example the other time. If you're writing a letter, if you are sending the letter to someone without writing the address of that person, right? The post office person, or the person that is going to send the letter, will not know the address of the person you are sending the letter to, right? So this same thing applies to to IP, to network, to how devices communicate to each other, right, through the network. So the network must actually know where exactly the device is so that it can go straight to the place, right? Now, the next one is just the MAC address, right? The next one is just the MAC address. When we say MAC address is what? A MAC address is a unique ID permanently attached to a device network card. It never changes. IP can change, right? An IP address can change. It depends on your location, right? But a MAC address, it never changes. Like, it never changes. It is always the same. Every devices have a different one. Every single device have a different one. So for example, this is the MAC address, right? This is an example of a MAC address. Obviously, this is not a MAC address because there's no way I'll put it here. But this is an example of a MAC address, right? So, and now, why do we really need MAC address? Why is MAC address really needed? MAC address is more like, when you are sending a letter to a person, the person you are sending the letter to, what do you need? You need, for example, the house number of that person. The house number of that person. Now, if you don't put the house number of that person, the person that is sending the letter, or the person that is taking the letter to the receiver, for example, right, we know that, okay, this is the area where the letter is supposed to be, but it won't know the exact house, who exactly is receiving the letter. It won't know the person, right, who exactly is receiving the letter. So the MAC address is more like, who exactly are you, right? Who are you receiving the letter? If you are the right person, right? So inside a local network, right, many devices exist. Like, many devices exist inside the local network. So the IP address can change. Like I said, the IP address can change, but the MAC addresses doesn't change. The MAC addresses doesn't change at all. So the network says, I know where you are, right? The network can say, I know where you are, meaning an IP address, but who are you exactly? That's the MAC address. but who are you exactly? That's the MAC address. All right. So, and then the last one is protocol. Oh, okay. I said here, even if IP changes, MAC stays the same. It always stay the same, like always, today, tomorrow, and forever. Always the same. All right. So now, who is a protocol? A protocol is a what? Is a set of rules that devices follow to what? To communicate. It is a set of rules that devices follow to communicate. And take for example, look at the letter I explained the other time, right? Now, imagine you are given this rule that okay, once you give the letter to the person, after reading it, share the letter, right? Or after reading it, just take the letter away from the person. This is the rule you are giving to the person that is going to what? Send the letter. So once the receiver reads the letter and is done consuming the information in the letter, the person sending the letter, the person that is going to give the receiver the letter can take the letter from the person and share it, because that's the rule you have given. And in this sense, that's the protocol. So it is a set of rules that devices follows to communicate. Like I said before, devices are not human, right? They don't have a name attached to them. They communicate through IP, through MAC, and through protocol. So protocol can answer questions like how should data be sent? How should it be sent? It can answer questions like what format should data be in? In what format? In what format should I send this data? Right? And what happens if data is lost? Are you with me? This is answers that protocol, answer, and these are questions that protocol answer. I will also touch this protocol um in the next class, like the part 2 of this course, right? And then just know that without protocol, devices will just send random data to anybody, more like the hub, right? The hub that I explained here. The device, where is it? More like the hub, right? It's blindly send data to every device. It just send data to anybody, right? And which is very old and vulnerable, which is weak, old and vulnerable, right? And then, for example, imagine if two persons speak, if there are two persons, just imagine there are two persons, one is speaking English and the other one is speaking Chinese, right? You see that if the person speaking English and the person speaking Chinese, they are talking to each other, there is no communication, because in communication you need the encoder, you need the information, and then you need the decoder. So if the encoder, that's the person that is speaking, that's we have the speaker and the listener, right? If the speaker is speaking English and the person listening doesn't understand English and is speaking Chinese, you see that there's no communication in that process. So for there to be communication, they both need to speak English. They both need to speak English properly so that they can speak in common language. Then in that sense, there will be what? Communication. All right. So now let's just go to some common protocols we have, some common network protocols we have, and I will explain what this protocol does and uh, how they function. You understand? So now the first one is TCP. We call it TCP. It is called Transmission Control Protocol, right? Now, when we say transmission control protocol ensures that what? Data is delivered completely, right? Everything is delivered completely. Data is transferred completely, it is delivered completely. One, and then data is delivered to the correct order. Are you with me? Data is delivered to the correct order. I mean, in the correct order. Sorry, I make mistakes every time. Please, apologies for the mistakes. Data is delivered in the correct order. And also, they make sure that missing data is what? Is recent. Is recent. Sorry, is recent. If there is any data missing, it will resend it. So their their main work, the main work of TCP is to ensure that data is just delivered completely. Everything is delivered, right? So it is more like TCP cares about, cares about the correctness, ensuring that data is correct, everything is sent completely and is correct and is intact. Are you with me? That is TCP. It sent it completely, correctly, and is intact. Imagine, for example, if I'm sending a 10-page document, right? A 10-page document to a courier, or I'm sending it through Uber, and then I'm sending it to your location, right? Now, if you are checking it, at the end of the day, you now discover that 5 pages is missing in this document. You see that there will be problem. So TCP ensures that every document I send, right, is delivered completely. It doesn't care if it's slow or not slow. That's not its problem. Just know that it is complete, right? That is just what TCP does, right? Ensuring that it is delivered successfully. So the next one is UDP. 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 And before I go to this UDP, right, let me just add something here before I forget it. We use TCP. We use TCP to actually to browse. We use them to browse, on the website. For example, like web browsing, we use them in HTTP, we use them in HTTPS. We use TCP to actually transfer data. I mean, to actually transfer files, yes. To actually transfer files, to actually send emails. We use TCP to send emails. We also use TCP to do SSH connection, right? We use TCP to do SSH connection, so if TCP breaks, just know in DevOps, just know it. If TCP breaks, then the application fails silently and nobody will even know, or it just hang. So that is why TCP is very, very important. Then the next one, as I said, UDP, this user datagram protocol. UDP, it is user datagram protocol, and then what it does is, it sends data very fast. It sends data very, very fast. It's all UDP, TCP sends data completely. It doesn't care if it's slow, but it just makes sure you send data completely. But UDP send data very, very fast. And UDP doesn't care if the data is complete or not. All it knows is sending the data very fast, right? And it does not check if data arrives. Are you with me? It does not check if data arrives. That's it. That's UDP. It does not check if the data arrives. Just the only thing, its only function is just to send data very fast. It will not check if it arrives or not. No. And if there is any data that is missing or lost, it will not resend it, because now that is not its work. TCP can resend data that are lost, but UDP will not resend any lost data, right? So UDP cares more about the speed, not the accuracy. It cares about the speed, not the accuracy. So imagine in what illustration can I give, right? Imagine if I'm sending the 10 pages document, right, to you, and then I send it through Uber, and then the Uber was just in a hurry, speed, like serious speed, driving very, very fast to your place. Then some of the documents just flew out all of a sudden, and then at the end of the day, what what the Uber driver is about is what? Delivering that document very, very fast. If there is any data or if there is any document that got lost during the process of driving to your place, the Uber driver doesn't care about it. So this is just what UDP does. That's the function. All right. The next one, the next one is HTTP, right? HTTP. So before I go to HTTP, lest I forget, let me just explain where we use UDP for, right? We use UDP, that's user datagram protocol. We use them in more of let me try and remember. Yes, we use them in more of live streaming videos, right? Live streaming videos, we use them in more of online gamings, like voice call, like DNS record. So you can see speed. You can see that UDP is involved in speed going around the world, streaming without any break in the stream, right? So it helps in real life system, where speed matters a lot, and then it matters more than even perfection. It is very, very important, right? So as is more this adds its advantages, this adds its disadvantages, and its advantages is that data are delivered completely, right? But it can be slow. Yes, it will be slow. But UDP data can be it can send data very, very fast, right? But doesn't care if the data is complete or not. Even if it's lost, even if the data gets lost, it will not send it. So that is that. The next one now is HTTP. HTTP is what we call hypertext transfer protocol. Let me say protocol, hypertext transfer protocol. And what HTTP does is, right, HTTP is the protocol used to actually request, right, to request web pages. You can use to request web pages. You can use it to actually send data between browsers and server. You can see here, to send data between browsers and server. For example, HTTP is how the web talks, right? HTTP is just how the web talks. Like for example, if a browser sends a request, right, the server will actually send a response. Are you with me? So it's more like someone communicating to another person. So if the person sends a request, being the browser, the server will then send the response and then deliver to the user. Easy. So to the next one, right? We have HTTPS, that's hypertext transfer protocol, which is secured, right? HTTPS. Now, it's what it does, it encrypts data, because in anything, security is very, very important. If you remove security from whatever you are doing or whichever you are doing, whatever, it will leave whatever you are doing vulnerable. It will leave that thing vulnerable, and at the end of the day, people can have access to what you are doing, and on the long run, you will lose a lot, right? So security is very, very important. So it encrypts data. It actually protects password and personal information. So it is important. And then it prevents attackers from reading data. So if you are visiting a website, which website can we actually visit? Let's say www. can we use Canva? Yeah, you can use Canva. If you check this place, right, you can see connection is secured. It is very secured. So this, you can see that this is using HTTPS in this sense because it shows that connection is secured. If you are going to browse or if you are going to visit any website, ensure you always check that if they are using the HTTPS, because it's very very important. Because at the end of the day, if it is not well secured, right, you'll be having problems. You'll be having problems a whole lot of time, right? So in the sense, right, HTTPS helps to what? Hide the information while sending it. It hides the information while sending it so that people will not see it, right? It hides the information while sending it. All right. So moving to the next one. The next one is sorry. The next one is DNS. Yeah, the next one is DNS. Sorry, I got a bit distracted. The next one is DNS, and DNS is what? DNS is domain name system. Domain name system. And what DNS does is, because like I said before, computers are not human. They don't have name, right? They don't have name. They only communicate, but they use a different styles. So what DNS does is it converts human-friendly names to IP addresses. It converts the human-friendly name to IP address because I said before, computer understand IP address, but they don't understand name. So, for example, if for example, okay, let's see, Google. Let me see if I can do it so that I will show you guys. What we are going to see, what we will see is just www.google.com. We humans can read this, right? But what computer will see in that sense will be the IP address, right? So if you type www.google, it can bring DNS. We convert this. You convert this www.google to what? To this IP address, right? So that is what DNS does, and we need DNS, right? Because without DNS, without DNS, we will always try to remember IP address a lot, right? Without DNS, we must, it's a must, not we must always try to remember the IP address, and then the internet will be what? Unusable. The internet will be unusable on the long run because there is no DNS, right? So all this works together, right, to provide what we are using today. So the next one is ports and sockets. The next one is ports and sockets. When we say ports and sockets, right? When data reaches computer, just listen to me, please. When data reaches computer, the computer must actually answer one question. The computer must answer one question, and the question is which application or service should receive this data. When the data reaches the computer must answer one question: which application or service should receive this data? And that is where the ports and socket comes in. So now, what is a port, right? A port is a number that identifies a specific service or application in a computer. And why do ports really exist? If you look at it, why do ports really exist? Let me just give you a quick scenario, right? A single computer can actually run many services at the same time. It can run many services at the same time. For example, it can run the web server, SSH remote login. It can run database. It can run email services. All these services, right? They can use what? They use the same IP address. But the question becomes that the data has arrived at the computer, but which program is the data for, right? Which program is the data for? So we can see that a port, right? A port is now a door that leads to a specific room in the house. For example, if we are coming in, right, You are, for example, you are just coming in. For example, you are the data, and then you come into a house that comes with different rooms, many rooms, right? A port, right? A port is a door that will actually lead you to specific room in the house. So in this sense, it leads the data to a specific place or a specific service in the computer. That's the port. So it is a number that identifies a specific service or application in a computer. That is port. And then or let me just give you an illustration so you understand this better. So for example, you are working as um let me you are working in an hotel, right? In an hotel, and then someone orders for food. A room orders for food, and after you've prepared the food, what will be the next thing you do? You take the food to the what? To the room. During the process of you taking the food to the room, maybe you enter the elevator, and then it gets you to the particular floor you are going to. You see that we'll be having many rooms, different rooms with different numbers in that particular floor, right? But you already know the rooms you are going to because the person already states it. The person already gives the number that, okay, this is from room 221 or room 220. You understand? So you know that you are going exactly to room 220, even though we have many doors. So now, in this sense, right, the doors that you see are the what? Are the ports. There are different ports we have. Are you with me? So the room inside that port, those room inside, they are more like the applications that we have in in the tech space or in the DevOps space. They are more like the application. So that is that. And then common ports with examples. We have common ports with examples. We have port and then their number services. We have port 22, port 22, right? Port 22 is what? SSH. You will know this later on when we begin to do some hands-on project. And then port 80 is what? HTTP. Then port 443 is for HTTPS. We have port 3306 for what? MySQL database. Port 5432, we have PostgreSQL. And then we have port 8080 for any alternative web server that that is available. So it is very, very important. So imagine that port 80 is closed. Just imagine that this port 80 is closed. The port that we are supposed to use to access a web server or a web service. Let me take for example. Imagine that this port is closed. You see that at the end of the day, the website will not load because this port is closed, right? Like I give an example of you trying to deliver the food to a room. Imagine that the person staying in the room did not open the door to that room. You see that you'll not be able to deliver the food easily. You'll not be able to deliver the food because the door is locked, right? So imagine this port is closed now. You not have access to this web, right? Imagine that port 22 is closed, SSH, where you have your remote login, where you can actually log in and do some things you need to do. Imagine that this port 22 is closed or port 22 is closed. You see that at the end of the day, you will not be able to log in or have access to this. You'll not be able to SSH, to your server. So it is very, very, very important. And then the next one is socket. When we say socket, what do we mean by socket? Now, this is where some beginners try to get confused, right? This is where you might get confused. So please don't get confused. I will try to explain to you. A socket is a connection point that combines what? IP address with the port and then the protocol. It connects this thing. The socket is a what? Connection point. The connection point that combines the IP address, the ports, and then the protocol. You can see what we have here. You can see the socket joins or combines the IP address, the port, and the protocol. That's the location, right? The room or the door, or the door number. Let's take for example, the door number and then the rules. Are you with me? So in simple words, right? Port is like the door number. Remember the hotel illustration I gave you? Port is like the door numbers, and then socket is like someone that is standing at the door, right? Socket is like someone that is standing at the door. At the end of the day, if you be giving the food, the food illustration I gave you, the hotel I gave you when you want to deliver the food. If you be giving the food, right? Imagine someone now standing at the door, right? And then you guys are actively talking. Where you exchange communication, when you guys talk, sir, this is your food. Can I take it in? And the person answered, oh yeah, you can take it in. That is a socket, right? So a port can exist without communication. This port can exist without communication. And then a socket can exist when only there is communication. It can exist when only there is communication. So we'll still know much about this thing whenever we are doing some hands-on project. It is very, very, very important. All right. So the next one is firewall. I don't want us to spend much time in a whole lot of time in this class. Let's see. Let me even see how many minutes we spent. It feels more than 1 hour. Let me just try to finish up. So what is firewall? I will explain firewall later in this course, right? Now, when we say firewall, right? A firewall is a security guard for a computer or a network. Firewall mainly works with what? Mainly work with ports. Are you with me? So for example, if you block the port here, you block this port, the work of firewall is to avoid anybody from accessing these ports. Or take for example, you gave a rule that do not allow anybody to access this port, HTTPS. You gave the rule. That's the protocol, right? The work of the firewall is to ensure that no one access these ports. Remember the illustration I gave you about a bouncer or a bodyguard. Imagine giving a bodyguard or a bouncer the rule that anybody that looks short or anybody with dreadlocks should not enter this event, right? The main work of the bodyguard or the security guard or the bouncer would be that looking at anybody that is with dreadlock or that is short according to the instructions you've given a person. So if a person with dreadlock is approaching the event, the work of the bodyguard will be to throw the person out, get out, right? Or to disallow the person from entering or to block the person instantly. So that is the work of firewall. So firewall is a security guard for a computer or a network. So if you don't want a particular thing from your computer or a network, right, you can make use of firewall. Firewall has the responsibility to actually block those things you don't want according to the rules that you give, right? So why firewalls exist? Firewalls exist if there were no firewalls, for example, right, anyone in the internet could access your computer. Anybody will have access to your computer if there's no firewall. If there's no firewall, hackers can actually connect to open services if there's no firewall. If there's no firewall, then malware could freely communicate to your computer or have access to your your laptops, whichever. So it is the firewall that is blocking the hacker from having access to the website, to your applications, or to whichever. Are you with me? So for example, I started an example when I told you that that is why it is important not to access Wi-Fi, any free Wi-Fi in public spaces, right? If it is because the firewall of that Wi-Fi is quite weak and there is no rules given, that is why many hackers can actually access Wi-Fi easily and then take control of, would I say, any devices they see there. You understand? So now, how a firewall works, how it works, right? This is straightforward. When a data tries to enter or leave, when a data tries to enter or leave, when a data tries to enter or leave, the firewall will check where it's coming from. One, it will check where it's going. Two, it will check which what port or protocol. Remember, this is very, very important. If you block the port to this and you gave the rules, right, the firewall will actually check it. Like, okay, this is what you want, and then applies the rule, right? And then it can decide to allow or to block according to the rules you have given here. So it will check where it is going, it will check where it is coming from, and then block or allow it. All right. So the next thing we'll be discussing now is the OSI model. Now, what do we mean by OSI model? When we say OSI model, right? OSI model is just a way to actually break network into layers. We'll be talking about network, and then we don't know, what we don't know is how data are transferred from one computer to another, right? This is just how data are transferred from one computer to another, or one network to another devices. Now let's take, for example, let me give you an example of this, right? Okay, let me try and clean this so that we don't have any problems. So what we know is that, take for example, this is a particular device. Sorry for that. All right, let's take for example, this is actually a particular device, and this is another device, right? And then one device is transferring data to another device here, right? Now, what we know that all we know is just that one device is transferring data, but the OSI model, right? The OSI model helps us to break down the phases or the steps that those data passes through before it reaches, this device. 1, 2, 3, 4, 5, 6, 7. So it passes through 7 steps. So if the data is coming from this particular device, right? If data is coming from this, if this device is sending data, it will pass through 1, 2, 3, 4, 5, 6, 7 steps before it reaches this data, these devices, and it all happens in like milliseconds, like very, 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 very fast, like milliseconds. It happens in in a tinkle of like less than a blink. It happens very, very, very fast. So now, instead of just seeing the network as a magic, right, that something just get transferred and it's received, right? the OSI models, right? Actually, the OSI models has shown it into 7 steps, like I said before. So we're just going to, you know, discuss about these 7 steps. But let me just give an illustration. So imagine just trying to send a message, right? The first thing you do is before you send the message, you type the message. That's the first thing you do, right? Before sending the message, you type the message first. After typing the message, you prepare it. It is now prepared, right? From typing the message, then you prepare it. Then the next thing you do is you package the message, right? The next thing you do is you address it to who? To who is this message going to? The next thing you do is you send the message. The next thing you do is what? When you send the message, the receiver will now receive the message and then open it. So this is the phases, or these are the steps taken for one message, or for one message to get to another person, right? These are just the simple steps you took. You wrote the message, you prepared it, you packaged it, you have the address to who is this message going to. You send the message, the person received it, and then the person opens the message. Instead of we just saying you send the message and then the person open the message, or the person read the message. So it is passing through these steps here, which is very, very, very important. So this is the same thing as OSI model. Now, why do network uses OSI model? It is very, very important because without these layers, right, everything will be mixed together. There will be no troubleshooting. Troubleshooting will be very, very, very impossible because it is from the OSI layers, or it is from these layers or this model you will begin to diagnose, or you begin to know where there is an issue or what is happening, right? But with layers, each layer does one job. Every layer has its own responsibility, its own problem, its own responsibility to take, right? And then problems are easily found, right? You find the problem and they are easily fixed. You find it and then they are fixed. So that is that. So we have 7 layers. We have 7 layers, the layers of OSI model. We have 7. We have application layer, we have the presentation layer, section layer, transport layer, network layer, data link layer, and then physical layer. Please try as much as possible to know this offhand, like without someone reading this to you, right? I can say it properly because it's something I interact with very, very well. So we have the application layer, the presentation layer, the section layer, the transport layer, the network layer, the data link layer, and then physical layer. Now let's now go into this part one after the other, right? One after the other. What is the application layer? When we say application layer, that's the last layer in descending order, right? This is the first layer in descending order, right? But this is the first layer in ascending order. So now, when we now say application layer is the what? Is the closest to the what? The end user. It provides network services to application, right? It is the closest. For example, this is the layer that is very, very close to the users, and it is where we have the browser, the email, the chat apps, then the net, and all these things, right? They use network, right? They use network, and this layer does not send data to itself, right? It just requests, network services. It doesn't send doesn't send data to itself, right? So, for example, if you open Google Chrome, the first thing you do is open Google Chrome, right? And you now type google.com. google.com. What will happen? You see that the Chrome uses application layer to actually request the web page. So it is Chrome, the application layer, that it uses what? The Chrome uses application layer to actually request the web page. So if I type it like this now, you see that it will bring something, to bring an interface, right? So because of the network, let's just proceed. All right. So now it is this application layer that is it is the closest to the end user, right? And then the sixth layer is presentation layer. When we say presentation layer formats, it encrypts and compresses data for the application layer to interpret. It formats it what? Encrypts it, compresses data for the application layer to actually interpret and then to send it out to the end user at the end of the day. So, and what it does is, in this layer, right, this layer actually prepares data. It prepares the data so that the other computer can understand it. So if you are sending data from this to this person, right, the application layer, the presentation layer will actually prepare the data so that the computer can understand whatever data you are sending in an encrypted form, right? In an encrypted form. So it compress the data. All right. So, and for example, right, if you're going to send a letter, if you're going to send a message to someone, right, before mailing a letter, what you do is what you translate it to a language that the receiver will understand, and then you lock it in an envelope. That's one thing you do. That's one thing this layer does. If you are sending the letter, you can't write English to someone who understands only Chinese. You see that there will be problems, right? So that's it. Then the fifth layer is section layer. When we say section layer actually manages connections, that's section, between computers, and then establishing, maintaining, and terminating them. So what it does is just that, this layer starts the section, it maintains it, and then ends a communication section between two devices. So once the data is being sent, what the section layer will do is it will start it will maintain it, and then it will now end the communication layer between these two devices, right? So that is what this section layer does. Then the fourth layer, which is transport layers. Transport layers, for example, when we say transport layer, right, it actually handles what? It handles end-to-end communication, like flow control, like segmentation, and then the error correction. It actually handles all this, end-to-end communication. Now, it ensures that what transport layer does is it ensures that data is delivered correctly. It is delivered correctly. It is delivered in what? It is delivered in order, and then data losses are handled. This is where the TCP works, right? This is where the TCP works. TCP and then the UDP, right? That's the user datagram protocol that I explained the other time. User datagram protocol and then transmission control protocol. They work well under the transport layer. They are under the transport layer because they ensure that data is being transferred correctly, data is delivered correctly and in order, and then they handle what? They handle losses. So if there is any data that is missing, they can handle it and resend it. So it is very, very important. All right. So let's go to the next one. The next one is network layer. Where is it? Yeah, network layer. So the network layer is responsible for logical addressing. That's the IP address and routing data packets, right, across network. This might seem too big for you, right? But let me explain it. What network layer does is it decides this layer, right? It decides where this data should go. So it answers this question: where should this data go, right? So in this sense, right, it handles the IP address, the routing between networks. The routing between networks it handles this. All right, let me just take for example, if you are driving and then you don't you are going to a new place, right, and you are using GPS for example, right, and then the GPS you're using gives you like different routes or different road to pass, but you now decided to what? The GPS now decided to actually choose the best route and the fastest route to your location to you, right? That is the work of a network layer. So that's the work of a network layer because it decides where data should go. So, and that's it. Then the second layer is data link layer. Data link layer, which is the penultimate, the second to the last layer. And what in data link layer provides node to node data transfer. That's MAC address, and handle physical addressing and error detection from the physical layer. That's the Ethernet. This is big English, right? Let me explain to you. Now, what this data layer does is that it actually delivers data within the same local network. It delivers data within the same local network, and it uses what? It uses MAC address. You remember MAC address don't change, right? So if there is a particular devices, let me show you. For example, this device has its own MAC address. This device also has its own MAC address. So, for example, if it's going to deliver a data, right, to this part, to these devices, it uses what? The MAC address of this device, so that we know that it is going straight up to these devices, and then it's packaged what? Data into frames. It's packaged data into frames as well, right? So, for example, we can say let me think of example. If we are using switches, right? Switches can actually deliver data to the correct desk. Switches, it delivers data to the correct desk in an office. So that is that about data layer. And the next one is physical layer. That's the last layer in OSI model. Physical layer is actually what is the actual hardware layer. The actual hardware layer. For example, now it's what? It transmits raw bit stream over physical mediums like what? Cable or radio signals. So this is the actual hardware layer that deals with the cables, that deals with the Wi-Fi signals, it deals with the fiber optic, it deals with more like electrical signals, right? So this is physical layer. And if this layer fails, then there will be problem, right? If this layer fails, then there will be problem. The cable is unplugged, then the Wi-Fi will off, the network will be dead, nothing will happen. So, and how the data moves? Let me show you how data moves through OSI. How data moves through OSI layers. Now, if you are sending from the sending computer, if you are sending if you are sending a data from the computer, it starts from here. It starts from the application. It starts from the application layer to the presentation layer to the section layer to the transport layer to the network layer to data link layer to physical layer, which is the last one. And then the receiving computer that receives the data will actually now start from what? Physical layer, data link layer, network layer, transport layer, section layer, presentation layer, and application layer. So it goes like this, like this. It goes like this, right? So that's what we have here. And then we have come to the end of this section. What we are going to be doing now is in the practical part, we'll be working on some real life projects, some projects that will help us understand these parts properly. Because networking in DevOps, right? The concept of network is something you cannot miss. It's something you cannot miss, and I hope we really understand this section properly and how OSI model works. It is very, very important because whenever you are interacting with any daily task, right, you really need to understand networking fundamentals properly, right? And especially OSI model. I know, like I said before, the seventh layer, is what, right? It is what the user uses, right? The sixth layer is how the data looks and how it is well secured. The fifth layer, it is what actually, the fifth layer, it is who actually who is still connected, right? The fifth layer, this is who is still connected. The first layer is how the data is delivered. The focus on how the data is delivered. The third layer is what? Where the data is going. Where is the data going? The second layer, right, which is data link, is what? Which device in LAN? Where is data is going? That's the third layer. Which device in what? In LAN. Look at it. Which device in LAN, like the local area network, which device? And it uses what? MAC to identify which exact device, right? And then the last layer is how bits move physically. How the bits move physically. So that is it about network. So I hope you understand this properly. And if you don't understand anything, trust me, drop your comment, bombard me with comments, write your questions. I would reply to you very, very fast. And in this sense, I will explain properly to you. And please try and follow me on my social media handles. Please, it's very, very important so that we stay connected. We stay connected. You can share your stories with me. If you have any problems, any question, any real world issues, or you are working on any task you don't understand, send me a DM. I will reply to you instantly. Thank you. I will see you in the next one. Kudos. Bye bye. Gosh.